everybody and welcome back to another video. In this video, I will be covering the integral of CSCx in two different ways, which I already covered in a previous video where I solved it with a non-typical method without the trick, and I will be showing you the trick in the second integral we did today. However, in this first integral, I will just be rewriting the answer we got in the last video. So if you want to watch that, just go look on my channel. It's one of my most popular. I believe the title is a solution to this unorthodox integral or something like that. So to begin, we are just going to write what this was equal to. The answer for this was 1/2 ln, this was a negative 1/2, of 1 plus cosine x over 1 minus cosine x plus c. So this was our answer from the last video. Now, we are going to use logarithmic properties as well as trigonometric properties on this. So to begin, we will take this negative, or we'll just take this 1/2 at first and put it on the inside, where this becomes ln of the square root of 1 plus cosine x over 1 minus cosine x plus c. Now this is negative. Now if you remember your rules, this negative will flip this fraction on the inside, as you will raise it to the negative first power, as you did right here where you raise it to the 1/2 power. So this will flip these insides, so this becomes ln of the absolute value of the square root of 1 plus, or sorry about that, 1 minus cosine x divided by 1 plus cosine x plus c. Now, this property probably doesn't look too familiar. It is not exactly common. However, this inside, so the square root of 1 minus cosine x divided by 1 plus cosine x is just tangent x divided by 2. So our answer can just be written as the absolute value of tangent x plus c. So this is one way that you will commonly see this written out. Now for the other method, we have to use a little bit of a weird technique. So this is the typical method that you will be shown, but it involves a trick which you kind of already need to know the final answer to understand. So what we are going to do is we are going to multiply the inside of our integral, CSCx, by the cotangent x plus CSCx on both the top and the bottom. So we are multiplying this and dx. Now we are going to set u equal to cotangent times cotangent plus CSCx. So we have u is equal to cot x plus CSCx. Now du is equal to the integral, or the derivative of cotangent x is just negative CSC squared x. Then the integral of CSCx is negative CSCx times cotangent x. So this is our du over dx. So if we solve for our du, or our dx, we get du divided by negative CSC squared x minus CSC cotangent x. CSC x times cosine x is equal to our dx. So now we are going to plug that in for our dx, and we are going to plug the bottom part in for our u, and we are also going to multiply this to the top part. So this becomes the integral of CSC times cotangent x is CSC x cotangent x plus the integral of, plus CSC x times CSC x, which is just CSC squared x. Then this is all going to be divided by our u, and then our du divided by this right here is going to be that. But if you look, this is just negative this. So this and this will cancel out, and a negative will be put on the outside. So this becomes negative times the integral of 1 over u du, which is just ln, negative ln, absolute value of u, plus c. So our answer is negative ln, absolute value, cotangent x, plus CSCX, plus c. And that is our answer. It is very different, so we have 3 different ways to represent this so far. This is our first, this is our second, and this is our third. It's getting less and less messy as we go along. Now, the reason I didn't show you this integral in the first video, although it has a lot less work, is because realistically, you will not think of this if you are just solving this integral. The only way to really solve this integral, unless if you're the first person who solved it kind of, is just to know what the answer to the integral is. So, anyway, I hope you enjoyed this video. And yes, all 3 of these functions, although they look very different, are all the same. So, I hope you enjoyed this video, and thank you for watching.